AI Diagnostics with Andy Sterland.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that AI, Azure, and the .NET ecosystem has to offer. My guest today on the show is Andy Sterland, and he is a principal PM manager at Microsoft, working in the CoreAI organization on Visual Studio and AI-powered developer tools. He leads program management and product management teams responsible for how Visual Studio is evolving into an AI-native IDE, including the GitHub Copilot integration, agent experiences, and the extensibility surface that the .NET community builds on. His background is in deep developer experience, and he spent over a decade shipping debuggers and diagnostic tooling, starting with Edge DevTools and continuing through JavaScript and Node, debugging in Visual Studio Code, so much in that space. And he's a regular contributor to the developer tools community, and he lives in the Pacific Northwest. Well, Andy, welcome to the show. How are you, sir?
Good, sir. Thank you very much for having me today.
Oh, my pleasure. My pleasure. I want to jump into our topic with AI and Visual Studio and diagnostics. But before I do, for the listeners who have not seen you speak at any of your events or heard you on any other avenues, I was asked, you've done quite a lot in your career, but if you kind of go back in time, what is it that hooked you about software engineering and kind of keeps you interested in this field after all these years?
Yeah, I think what really hooked me was in university. So back in England, far too long ago, back as a student, I took part in a competition called the Imagine Cup, which Microsoft runs, and it still does. This was probably one of the first couple of them, so it's that old. And it was just so exciting taking part of that. Firstly, like my local university, the idea is you get a team together of students, you build something that fits the theme of the competition. That's, like a building application. At the time, it was .NET on a compact. So the PDAs where you used to have styluses to talk to, right. There's, again, web services are almost new bag now, right. Like XML everywhere. And so that, going that experience really got me hooked, going from, just seeing all the different energy and excitement from all these different people building these applications, and just the fun of, building tools, building, software together with a few people that you really get along with. And in my case, I'm still in touch with, 20 odd years later. But even before that, I think my journey with computers started way back on 286s, where I'm still traumatized by setting a BIOS password or a CMOS password to turtles at an age at which I couldn't spell, for which completely
locked you out.
I think absolutely. So I think my dad's still angry about that one. Back when, 4 megabytes of RAM would have been an unheard of expense. So I think it's been fantastic to see the evolution from those days with BASIC all the way to now, which is just, phenomenal.
Yeah, absolutely. Absolutely. Where, we can't, these little tiny systems on a chip have more power than computers did 40 years ago, or maybe even 30 years ago.
Yeah, I'm sure I saw a stat somewhere where some of the images on the internet, a typical photo is more than takes up more memory than the Super Mario on the SNES or SNES, which is kind of crazy, but there you go.
Right. Well, your focus has been in Visual Studio and AI and diagnostics, and so much of the discussion is around the command line interface tools for AI coding. And so, just at the highest level, how do you think about all of the available AI toolings, and how do you set yourself up and in your team when you have all these choices, and when to have Visual Studio, VS Code, or just a terminal?
Yeah. So I think that command lines are fantastic for LLMs. Obviously, their text-based is what they're all built around. But for people, visual interfaces, I think hand down, I think you'd have to have a very difficult argument to convince me that merging something in a terminal window is easier than using a diff tool.
Yeah.
Let alone debugging or profiling. Fantastic. Like an LLM can read 100,000 lines of profiling code, output from a trace. People can't. And so I think that the opportunity for Visual Studio and for us broadly is trying to bridge the gap between the two, essentially, the right tool for the right job. Like it's always been that case where, the agentic loop in a terminal makes tons of sense when you're generating new code, trying to iterate rapidly and, you've got your browser up and you're prototyping sort of thing. But, later on, like when you're debugging and stuff, the context that's available to the LLM, the terminal can be sure, it's just the output basically. So, if there isn't a log or an exception, the terminal can't do anything because it doesn't know anything.
Yeah.
And then of course for humans, you can't debug that way. You can rewrite it and you can keep trying to rewrite it and you can yell at the LLM, louder and louder to rewrite it a different way. But ultimately, so long as there needs to be a human in the loop, a developer, I think tools like Visual Studio still have a huge part to play in helping developers comprehend code and, to be honest, take accountability, responsibility for it, because you've got to decide as a developer if this code, is the code you want to check in and, for your company to live with for decades in some cases, frankly. So, I think that's where, I think VS is especially strong is really for those, how should I say, when you have applications that, have grown over time and they're not trivial, they're not something you could necessarily run in an LM loop that well. These days you're bombarded by PRs, but you need time to validate those and take accountability for them. That code is an asset for your company, not just something that'll be thrown away tomorrow in terms of having another cool little prototype.
Right. That's a great point. There's so much talk and buzz around just vibe coding and using a terminal window and just not even paying attention to, and then it works on my box. Yeah, that's all great for just prototyping or personal software, but real software gets real hairy real fast, and then we have to actually understand the structure of it, and the terminal's not good for that. How do you when do you go for VS Code versus the full Visual Studio?
Yeah, so for me personally, I think the first pivot really is around the language. I think like it is for most people. Like I had said historically, if I was writing a Node.js or a TypeScript application, VS Code is perfectly well suited to that. It works well with folders, it works well with NPM, etc. And that's just great. There's it's a pick your own toolbox, right? I've chosen a command line I like, I've chosen the editor I like, I've chosen the browser and the debugger in that I like. And then I think for other languages like C# and C++, I switched to Visual Studio because they're really strong. And in most of the time in those applications, I'm running the application and trying to, like debug, or something like that. So I need to see these extra bits of information where it's not just like, make a change and rapidly see a updated web page. Often like there's a scenario or a repo steps to run through and stuff like that. So things like edit continue are super useful, or, in C++ patch and continue type things. So that's when I kind of make that decision. It's primarily firstly based around the language, really, and then what I want to achieve. Like, I'd say until recently, when Visual Studio's Markdown got a lot better, I would have used VS Code for Markdown, just because it's lightweight. You just want to edit text file, done. But anything beyond that, I think I'd lean to VS, especially for compiled languages.
Yeah, and man, Visual Studio 2026, night and day load time from a speed perspective. So that old argument's out the window. Even as a consideration, because it's lightning fast, or it's the same speed of VS Code right now, I guess, on my box.
Yeah, I mean, that's one of the big things we focus on is making the startup speed much, much faster. And so, both doing less work, which is the only way you can make things faster, really, and then deferring work to when it's needed. So you can get that experience of having it open straight away. Like, even if IntelliSense still takes a few seconds to load, but you're unlikely to want to need IntelliSense within a few seconds of opening Visual Studio anyway.
Right. So I've, for the last 25 years, I've kind of grown up with Visual Studio and gotten really accustomed to having things on all of my monitors and having all the windows, kind of a real cockpit, and and with all the debugging tools, they've always been strong for years and years. And so I'm curious, when you have meetings with your colleagues, especially, since Thanksgiving, Christmas, it's kind of the Opus wave where now it's like, whoa, okay, now AI is for real in a whole different
Yeah.
level. How have the conversations changed regarding what you're used to talking about with debugging and observability and fixing and finding problems?
Yeah. I think the thing that's really changed, like firstly internally, is the usage of things that since Opus or other things has really increased. Like I say early on in the LLM, like how you say generations, the Visual Studio code base, I'm sure you can imagine, is very big, very old, has more design patterns and more frameworks. Literally everything Microsoft has ever invented at some point, even
It's in
Silverlight,
there.
has been shipped to Visual Studio.
Right.
So like, I think I would have said the early versions didn't do so well. I mean, firstly, that was a combination of like the window context, window size, perhaps the reasoning models behind them. But the other thing I think is the maturity of the tools around it. So for example, one of the benefits we really found was using, custom skills or custom instructions, things like that, to try to, guide the LLM to know how to build the code base. Because, like many parts of our code base require setup before you can build them. Some are just, you could press F5, launch this is Visual Studio for sure. Others, less so. Depends where you work. So, building out skills that, talk about style, about abstractions we use or libraries, I think that has really helped. So the biggest change I've noticed really is if you imagine our adoption, like internally, it's literally gone really high in terms of, developers being able to use AI to build Visual Studio, and subsequently do the other things you mentioned, like diagnose it and, use the tools against it.
Talk about that. You mentioned adoption going high. How do you, what are those numbers and what visibility do you have on that?
Yeah, I mean, I think like most people, and certainly if you use a GitHub Copilot, you can see the metrics across your organization, like how many tokens or AI credits people are using across your org and how frequently and things like that. So, I think we've seen both the increase in tokens like per turn or like per user, but also just the number of people, how frequently they use it. Like I think like, if you look back, I guess 2 years almost or so, I'd have to look at the calendar, you would see people sporadically using it, like, and then they kind of go away. Like they wouldn't use it for days on end. Like, either that was indicative of them trying it out, being unsuccessful and just going right back to normal. And now like you can definitely see a trend where people are using it and they continue to stick with it and use it even more and more, and see that usage. And I think like all companies, at some point, we're very fortunate here that our developers have such generous token allotments, but I can imagine over time that, of course, with this recent launch, especially for GitHub, of like that being much more critical, because they now are direct. How should you say? I would say previously they were heavily subsidized, and now there's a much more direct, transparent cost to users.
Yeah. Now, has that affected the cost issue, how you and your colleagues actually use your tools and having to look at budgets?
Yeah, so for individuals, I don't really think so. I think that, I can certainly appreciate like our customers and in conversations with them, thinking about how they get returns on those things, because it's very hard to measure developer productivity. It's something that, there's been many, many fine papers out over time, and some people settle on things like, like lines of code. That's a great measure. I can think in many ways, I'm sure you can, of that being terrible. First and foremostly, some of the best engineers remove code rather than adding it. So it's like a terrible measure. But that aside, so it's really hard to quantify. And now you're being asked, to potentially pay thousands of dollars. Like it obviously depends on your usage, and how do you quantify or justify that? So I think luckily for us, like individuals, I wouldn't say have changed too much. I would say some of the more generous automated things where you might have a bot that goes around and does a lot of things, people might be thinking more seriously about, like, we've got like 1,000 repos. Let's have a bot do something on all of those, like run some sort of batched, a prompt, etc., against those, because like, the value of those might be diminishing at some point. So I think that, it's going to really sharpen the focus on, the value essentially there in terms of like, hey, these things cost money. Now am I getting their value? And I think at the same time, just around for a little bit more for us in Visual Studio, it's also an opportunity because I think some of the sweet spots of Visual Studio are really a combination of, our traditional static tooling combined with LLMs. You don't need to use an LLM to spot a missing semicolon. You totally can, and many people do. But that combination, like what you see in our profiler, where it's like, hey, we have some heuristics, some knowledge, some insights, and we can apply that to to the LLM, create prompts for it and guide it into what it's really good at, which is text generation.
Yep.
Like, it's not an expert on performance, like, clearly, but it is really good at text generation. Like, that's what it does. And so, I think that's one thing that, hopefully we're repositioned to do, is making sure that the time is spent optimally.
Yeah. Well, mentioning that, I think there's a lot of listeners who don't really understand where the .NET SDK ends and Visual Studio or some of the other tooling begins.
Yeah, I mean, I think it really depends on sort of the application. If you're building a framework application, I'd say Visual Studio is much more entangled, with MS Build and those components. So that's one obvious path, right? And we still have a lot of customers, like, if applications work, keep them working. There's no point, fixing a wheel that isn't broken, sort of thing. It ain't broke, don't fix it. So, like, for those, there's still, I'd say a very close relationship with .NET. Obviously, the modern one, I think that the biggest thing is really how Visual Studio connects some of the dots in terms of, being able to build and configure from UI menus and things like that. So it's easier to get started and change. Fundamentally, the source code works in both. So one of our goals, obviously, is that if you're using any editor and you're using a modern .NET project, you should be able to use any editor. Like, it isn't the case where you're essentially tied to use one particular IDE just because the build format or the configuration files are aren't readable. It's more the case that we want the source code to work in VS Code, work in other products, etc., even Notepad if you really like, anywhere, and obviously for agents too. And recently we've taken steps to do that. Like, for example, SLN files, which have been around for very, very, very many years, famous for having lots and lots of GUIDs, probably more than SharePoint even, which is saying something. But now it's human readable. We changed it so that, the idea is that, like, people can edit it, because that was what we were seeing, is especially as you use editors that are more like disk focused, for lack of a better word, they need to edit those files. And so having it human readable, which wasn't the intent. The intent of that file originally was always for consumption by a tool. So it doesn't matter, it could have been binary. In fact, some of our files that store things like break settings and other things are binary formats. So again, we're trying to move away from and make them text-based so they can be put into merge tool. You can look at them as human and make decisions around them, etc.
Gotcha. Well, can you help us demystify then the differences with Copilot as implemented in Visual Studio versus command line, VS Code, and how you guys have tried to differentiate the one that's inside Visual Studio?
Yeah, I mean, firstly, I'd say that gap is closing. You could imagine those three front ends, VS Code, VS, and the CLI, are all essentially like client applications that are consuming a service, which is GitHub. And so the fundamental models and a lot of the capabilities that wrap around the models, such as like filtering and things like that, are all part of the service. And so they've persisted the same for like settings for like organizations, like policies and stuff like that, which makes tons of sense because they're best enforced at the service. And each of the three clients would have their own agentic loop, for lack of a better word. We would integrate those best by each, client would provide their own tools. So Visual Studio has tools for like writing to files, finding symbols, stuff like that. And each of the capabilities were different across those, both in terms of those tools they were providing, but also in terms of like what they supported in terms of upcoming standards. Like if you support MCP servers, skills, agents, or custom instructions, or various parts of the MCP set, like prompts and solicitation, blah, blah, blah. There are tons of stuff. And because they're all developing separately, they all had different, capabilities at different times. And part of that, I think part of the role of the clients was to make sure the integration makes sense, like picking on it for their modality. So take solicitation, where MCP server can ask the user for an input. Like clearly in the context of a command line, that's dead easy. You just type in the text. But in VS and VS Code, there needs to be some UI, like whether that's a dialogue that pops up, an inline chat thing, or something else, like a picker for dates or times, whatever. Those are all options that you've got to address. So I think what's different in each is really that interaction. Like in Visual Studio, customers interact with a certain way, and it's somewhat similar in VS Code because they're both UI. Then the other thing is, of course, the tools and capabilities that each of those clients have, which is really dependent upon where they are in their development cycle. And the last thing I think, that we announced at Build was the one thing we're trying to do is converge on a singular agentic loop essentially using the Copilot SDK, which is a fairly recent thing, and anyone can use it. It's an SDK, that you can imagine as actually the heart of the CLI, and then build upon that. So, all our customers have a similar experience in terms of the capabilities, at least. So you don't have to look like a feature matrix to see which is supported where. But obviously the UI and interactions and things like that need to be different in each.
Yeah. So, speaking of MS Build and kind of the announcements for, there's so much content that gets generated at any of those conferences and too much to keep up. And for those who are still trying to catch up on announcements, what enhancements in Visual Studio or in the diagnostic space should people make sure not to miss about what was announced at?
Yeah, I think the two big ones. One I mentioned about using the same agentic loop as the CLI and VS Code is also moving that way. And then the other one is we're expanding our bring your own keys scenario. So today the Copilot service, you obviously have a GitHub account and Copilot. For a while, we've supported the idea of bringing your own keys from you can set up something in Foundry or Olama or whatever.
Mm-hmm.
And now we're opening up so you don't necessarily require a GitHub account. So that'll enable customers in scenarios where that might not make sense, average user regulations or simple company policy, etc., where potentially they could provide their own instance or use one that does fit their company's requirements. So I think that's the biggest change, which will hopefully enable a lot of customers and companies who have, stringent requirements around models and model access. The ability to moderate that and enable their developers to have access to AI while meeting whatever requirements they have.
Yeah. Okay. One thing I have tried is the Olama integration and figuring out what models could even do anything running on my own hardware running the RTX 5090. Which anything beyond that is now you're going way up in the price point. Has your team done any kind of investigations into what useful profiles are even possible just on a local workstation?
Yeah, no, certainly. So I think there's two ways. One is if there's specific tasks that can be offloaded to SLMs, smaller purpose language models.
Mm-hmm.
To be fair, Visual Studio currently ships one in the sense it's not a language model, like IntelliCode, a feature in Visual Studio for some time, where it's not an LLM, to be very clear, or a transformer. But it enables you to have code generation with offline. So you don't need to run it in the cloud or, on a big EFI H100 or whatever, and you can run locally. So I think, that's something we'll always consider is are there scenarios that are specific that we can offload? In that particular case, it's very specifically for C#. So, LLMs today, they can tell you how to make a chicken tikka masala as much as they can tell you, how to travel around the world and visit London or something, as well as write your C# code. Right. So hopefully by the idea of having a more domain-specific purpose-built model, we could provide performance and the capability to run offline. So I think that's going to be a trend in the next few years for everybody, right, is trying to find these more deliberate models that can scale to applications without having to scale the huge hardware in the cloud that is tremendously expensive. And so I think that's one general case. And then I think the other thing we do try is just hey, can you just use it like you were doing? It's an OpenAI endpoint or however you want to describe it. Can I just run any model? And you can totally do that, but it is a challenge in terms of the throughput, obviously, the models and what models you can run without getting incredibly expensive hardware, which at the same time is coming down in price. I think everything, the NVIDIA obviously announced a bunch of new hardware along with us that will hopefully make more of these things possible. And, I think the cost per token or however you want to think about that is only going to come down over time.
Yeah.
At the same time, of course, people's consumption of things is going up. So it's a bit of a race.
So just to be clear, so right now, regardless of what may happen in the future, right now, you and your team really haven't gravitated towards connecting Visual Studio Copilot to local models just yet.
Yeah, because we just don't see the performance for most hardware, certainly most of our customers, even at the high end, to be honest, because it's just too general purpose. So the other thing that, we specifically look at is specific scenarios, some of the, in Windows Foundry, they have some specific scenarios for generating captions for images or text-to-speech type stuff. Yeah. So those things might make sense if we supported those, but we haven't seen a lot of, use cases that really make sense to invest in for that.
Yeah.
So right now it's more the case that unless you have a beefy hardware, it's probably
data center beefy, not even an RTX 5090.
Yeah, if you get one of those, like,
that's not beefy.
no, I think the probably, like, I haven't got one. I wish I had one of those NVIDIA Spark devices, the DX ones, where it's like, a $3,000 dedicated machine. So if only.
Right. Well, one of so I personally have done some testing on the RTX 5090 and concluded it's like this isn't anywhere close to even be able to be useful. Okay, text to speech and some of those really small stuff, yes. If I needed a batch job that just had, but a colleague who did do some testing on the Spark with 128 gigs, and he could run a few more interesting, but still not even close to being able to be usable when connected to Copilot. So,
I mean, and it's not even a general Copilot. I try to think what the RTX 5090 like throughput per tokens is for a large model. Like, say it's something like, I don't know, 20, 30 or something like that. I forget. But you're putting hundreds of thousands of tokens through the thing.
Yeah.
So there's just no way it can work. Like completions, I think, is a place where we're closest to having something. Like some of the completions, like fill in the middle type things, where it's like, we give it the top and the tail of the function. That I could see happening in the shorter term, but it's also the lower value. Like, it's like, it's not the agentic loop that everyone wants or expects, because like tool cooling obviously can chew an obscene amount of tokens. So like I said, the token demand is increasing and the hardware is scaling, but it's not fast enough. Maybe it'll plateau, as you can imagine. Like on the one hand, we get to the point where models aren't advancing as fast, or people's consumption of tokens in specific turns is increasing and hardware is catching up.
Well, the Microsoft specific models that were announced at Build, anybody on your team been able to put in the paces yet?
Yeah, no, we tested, I think, the Fine model, I forget the name, we have done, but I think like you discovered that they're just not suitable for general purpose cases now. Like, unless for some reason you can afford a batch to take a very long time, like offline, more than go get a cup of coffee, they're just not suited for it. Like,
well, one thing that's also come out just recently, if people haven't been paying attention, is the more built-in agents in Visual Studio, the @debugger, @profiler, @test, and then of course people are hearing about skills and then sub agents. But can you kind of demystify what are now these primitives, or what is the domain model of Copilot now, and the differences between a skill and using @profiler? Just what exactly is that for the listeners?
Yeah, so I try to have so in Visual Studio, like we have this concept of what used to be called chat responders. Like we've had @debugger essentially before agents were a thing, really. And agents obviously just markdown files that have a name and some metadata and a prompt basically. And they can specify tools that they use. And the @profiler and @debugger are more, how should I say, they coordinate. So the idea is, of course, that like, hey, you ask this to a profiling job, and it can set off a chain of events, not a single like turn of the crank. It can interact with different components of Visual Studio, trigger different things, and it has an associated set of tools, like obviously launching the profiler, things like that. So each of those agents have a domain, a set of tools that they use, and the @profiler isn't like a markdown file you're talking to. It's essentially some C# code that's going to try to make inference and next steps based on the content you pass it. So they're really different things. Like we've kind of settled on a modality for each of them, which is and they're very different things. Like these markdown files are incredibly limiting in terms of what you can do with them. Even if you provide tools and you provide all our capabilities of Visual Studio's tools, you're still delegating to the LLM when to use those tools, which it may work out for sure, but it's not solid. Like, I don't need to, like I joked about earlier, use a tool call to figure out how to fix a semicolon. Like, you can just do that ahead of time. Like, there's no bother. Why waste tokens? So, like, scenarios like that where potentially as LLMs gets, and this has been a bit of a race, is like as LLMs get smarter, or not necessarily smart, that's a terrible term to use for them, as they generate more accurate code, perhaps there is a race where at some point they're better. Like, one of the challenges that struggles, I think we always wrap our heads around is like the search. Like, Visual Studio through Roslyn has a really great search semantics to look up symbols and stuff like that. Obviously, no LLM text transformer understands symbols. They don't understand C# in the slightest, obviously. So maybe there's value that we can provide there. On the flip side, grep can do just as well in many scenarios. Like, the scenarios where grep doesn't do so well are things like if you had to follow a reference into a package that isn't loaded, etc., or isn't available on disk. We can do that because in Visual Studio, we have source link and NuGet packages that we can follow and, go to the actual file, which is very difficult for an LM to do. Maybe in time they'll be able to do that. So there's a bit of an arms race in terms of, what the tools versus what brute force will do. It's like, we'll just grep everything. Like, how bad can it be?
Fantastic. Inside Visual Studio, you guys are integrating Copilot with all the diagnostic tools, and there's so many windows and different things in Visual Studio. Which parts of the actual IDE have already been instrumented, and which parts still are not instrumented, where you could just tell a prompt to do something, and then some part of Visual Studio reacts to that?
Yeah, I mean, there's no simple answer to that. Like, I think the integration of Visual Studio is kind of two forms. One is UI, where we have a button to trigger a code review, so you don't have to write a prompt. That's all it's doing, is it's saving you writing a prompt, which you could do by yourself. It just take time, submit, and then the other parts that we've been gradually doing is exposing more and more capabilities. So recently we exposed the ability to reference commits and branches and stuff like that. And so for the debugger, it's things like call stacks, exceptions, variables, things like that, that's accessible to both you like through your prompts as well as the debugger agent or profiler agent, etc. So right now it's really the core ability to inspect, to set breakpoints, to start the profiler, analyze the output from the profiler, which is tailored to it. And then, but over time, what's available is growing, is more and more pieces are exposed as context beyond just files, because the big difference, I think, between VS and a lot of the other scenarios is everything else is just running off files on disk.
Mm-hmm.
Like that's, files on disk and output from SD, SDIO type stuff. Whereas in VS, we have a much richer set of information, for async tasks and other things that are not necessarily as available. If you're just having, a command line experience that doesn't have potentially an MCP server or something else that can get that data.
Yeah. Okay. And kind of as we close up and wrap up here, I'd like to get your guess or get your thought. And it's not existing now, but just in my own observation with not only Visual Studio, but in Windows and other applications in general, we've kind of been conditioned a little bit with saying, hey Siri or Alexa, do this, or hey Google. And at one time it was supposed to be, hey Cortana, do the word Windows.
Yeah.
But at some point, I would imagine we're going to want to be able to say, hey Windows, hide my desktop, or hey Windows, I don't know, fix my Wi-Fi or repair the Bluetooth or just something.
Yeah.
And what is your guess? What is likely to happen? Is it more likely to happen that every application is going to gain some protocol for exposing a command line that then the LLM can just call some PowerShell? Or is every application going to gain some protocol for exposing some instrumentation to be able to be poked at and used by something other than the GUI?
Yeah, I mean, I think what's going to happen, if I was betting, is the accessibility interfaces that many applications already had to support screen readers and alternative reading mediums will be that interface. Like that's the thing that LLMs can, you can see that today, like we use it and a bunch of people use those interfaces because they provide, a way to interact with GUIs without using UI. That's like fundamentally what they're for screen readers, for Braille keyboards, all that sort of stuff. And so it's a programmatic interface over UI. Windows has them, Apple has them in their system, their platform serves Android, obviously. And so I think Windows is going to, basically use those, like the computer user agent using agents you see and stuff. That's a super effective way to drive it. It's how many people test their applications anyway. Like if yesteryear, hopefully you didn't write a test application by saying, mouse click at 100 by 100 offset or something like that. You instead use the accessibility interfaces. So there's already lots of precedent for driving programmatically applications, UI applications that can be exposed that way. So that's what my guess would be.
Okay. Awesome. Yeah, I think that conversation with anyone who's doing native applications, that's the natural next conversation. It's like, okay, is it a walled garden or is it now accessible via a prompt just because it's installed on the computer? So
Yeah, I mean, especially because things like Claw and Open Claw and stuff like that, they really want to drive applications, right? And they will totally do that without expecting the application to update or change or modify. The other way, of course, that people are doing is things like Playwright, which are also driving, in the case of Playwright in the browser, the web interfaces, the WebDriver interfaces, which are again designed for testing programmatic access.
Yeah.
So I can only think that's the path they're going to take, is the path of least resistance.
Right. Absolutely. So as we close down here, for folks wanting to kind of get on your calendar, see where you're speaking next, where can they find out more information about you?
I'm Andy Sterland on both LinkedIn and X or Twitter. So feel free to see me there. I think I do a lot less speaking these days. I have so many wonderful people on my team who speak and do a much better job than I. So plenty of conferences like VS Live, Build, Ignite, and local user groups as well.
Awesome. We'll include a link to all those locations in the show notes. Well, Andy, thanks so much for coming on the podcast and visiting with me. I appreciate it.
Cool. Thank you for your time. It was great talking to you.
Oh, my pleasure. My pleasure. And until next time, dear listener, keep shipping.
You've been listening to the AI DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.